Hi, we're going to continue our study of parabolas and their important features. Today our goal from a standard form equation, here's an example of a standard form equation, we are going to find the line of symmetry and we are going to find the vertex. I'm going to walk you through those steps. First of all, knowing that standard form is probably the most commonly used form, but not necessarily that helpful for graphing, we're going to first transfer this into a different form that gives us a little bit more information. So the first thing we're going to do is we're going to write x squared plus 4x plus 3 in factored form. When we factor, we have x and we want a product to be 3, so we want a factor pair that multiplies to 3, that adds up to 4. So we're going to use 1 and 3, so x plus 1, x plus 3 is our factored form. Then, over the last couple of days, we have used the zero product property and let y equal 0, knowing that letting y equal 0 gives us x-intercepts. So I'll take factored form and set it equal to 0, and I will get x equals negative 1 and x equals negative 3 as the two values that make intercepts. I'll then plot those two values on my graph, negative 1 and negative 3. Those two are my x-intercepts. Now we've talked a little bit about how important symmetry is, and this is a place where symmetry becomes really important, because we know this is a parabola because it's an x squared. And knowing that it's a parabola, all of our points have to be symmetric about the line of symmetry. So the key thing to know is that the line of symmetry goes perfectly through the middle of those two x-intercepts. So halfway between those two dots is the line of symmetry. Well, that's negative 1 and that's negative 3. So graphically, you can see that the line of symmetry must go right between the two. That is x equals, x equals negative 2 for the line of symmetry. The other way to do it, knowing that, just as a side note, knowing that negative 1, 0 and negative 3, 0 are your x-intercepts, you can find the average of negative 1 and negative 3 by adding them together and dividing by 2. That's negative 4 over 2, which gives you a value of negative 2, which is the same as what we found graphically. So knowing that x equals negative 2 is the x value for the line of symmetry, we can then find the vertex by letting x equal negative 2 in one of our two original equations. I'll do the standard form equation first. If I put in negative 2, I get negative 2 squared plus 4 times negative 2 plus 3. If I square negative 2, I get 4. I'll do my multiplication next, negative 8. And I add those three together. 4 plus negative 8 is negative 4. I add 3, I get negative 1. So the y-coordinate of the vertex is negative 1, which then, if I put them together into an ordered pair, negative 2, negative 1 is the ordered pair for the vertex, which is left 2, down 1. The vertex would be right there. And we would have a parabola that is concave up, which is consistent with our lead term having a positive coefficient. We'll go ahead and do one more example here. We have an equation in standard form, and we would like to have the line of symmetry and the vertex. The line of symmetry, one way of finding that line of symmetry is going through the x-intercepts. I'm going to first go and write this in factored form. I'm going to use a factor pair of negative 21 that adds up to negative 4. That could be 1 and 21, 3 and 7. Looks like 3 and 7, as long as the 7 is negative, is going to be what we want. X plus 3, x minus 7. That gives me x-intercepts of negative 3, 0 and positive 7, 0. It's going to be a little bit more challenging to graph here, but 7, and if there's 3 here and 7 here, we know that those are a total of 10 units apart. Halfway gets me 5 units, so 5 units from the far left gets us to x equals 2, 5 units from the right gets us to x equals 2, and our line of symmetry is the line x equals 2. using either standard form or factored form. I'm actually going to use factored form this time, and I'm going to let x be 2, just to show you that it can be done either way. I'll put x equals 2 in for both of the x's, and we will get y equals 5 times 2 minus 7 is negative 5. So 5 times negative 5, that vertex, that y-coordinate of the vertex, forgive me there, y-coordinate of the vertex would be negative 25. So our vertex for this parabola would be 2 comma negative 25. One more quick example here. Let's say I had something like y equals negative x squared plus 4. Factored form is a little bit more challenging, but if you go back to our factoring unit, it's always a good idea, if that lead term is negative, to take that negative out of the front. So I've got negative 1, x squared minus 4, and then if I want to write this as x squared plus 0x minus 4, it makes it a little easier to see what the factorization would be. X plus 2 and x minus 2, which gives us, if I set that equal to 0 using the zero product property, gives me x-intercepts at negative 2 and at positive 2. Making a plot of those at positive 2 and at negative 2, there's an intercept. There's an intercept. Halfway between those is x equals 0, which is the y-axis, and there's our axis of symmetry. And if I plug in 0 to the original standard form equation, I get y equals 4. 1, 2, 3, 4. And you'll notice the vertex is above the x-intercepts, which is indicative of the fact that the negative in front makes our parabola concave down. I think it's worth noting there's another formula that's given for the line of symmetry, and I think it's worth testing here. The line of symmetry follows the formula x equals negative b over 2a. So we can use our standard form with a, b, and c and identify those parameters. So the line of symmetry would be x equals negative b, and in this case b is 6, divided by 2 times a, and a is negative 3. I'm pulling those from here and here, and if I simplify that fraction, negative 6 divided by negative 6, the line of symmetry is x equals 1. That's something that can help me along the way here. As a side note, if you were to factor this, you'd factor out a negative 3, and you'd have x squared minus 2x minus 15, which factors to x minus 5, x plus 3. And you'll notice that at positive 5 and negative 3 are 8 units apart. 4 units in from 5 and 4 units in from negative 3 are x equals 1, and that's another way to get your line of symmetry. The last step then to get the vertex would be negative 3 times 1 squared plus 6 times 1 plus 45. Doing a little arithmetic here. Negative 3 plus 6 is 3, plus 45 is 48. So your vertex would be 1 comma 48. And you'll notice that's a pretty big y-coordinate for the vertex. Has to do with the negative 3, and would be above those x-intercepts because of the concave down. Go ahead and start the homework, and good luck to you. We'll see you tomorrow.